IT consulting. I'm going to do more of an introduction to him when he comes into the room afterwards to ask questions. This is the point I'm allowed to sound like one of those terrible American TV shows where I can say, "I'm now live from the room next door." We have David Alexander, who will actually do the demonstration and be available for questions afterwards. Thank you, David.
Thank you, Paul. Hello, everybody. I'll be through to see you in a minute, but let's do this demonstration first. Some of you have seen this already, but for those who haven't, what we have here is a system that is not so much a simulator. This is a real-life working industrial control system and security operations centre built into the stand. If you want to come and have a look at it afterwards, you're most welcome to. What we have up on the top here is a representation of part of a refinery. We have a storage tank here, a pipeline that's bringing refined product into that tank, and another pipeline that is taking refined product out to a loading jetty. Down here we have a PLC. This is a real Vago PLC, which is actually controlling the ratio between this pipeline and this one to keep balance in the tank central. So if we move down now and look at the HMI, so the screen here, this is a representation of what the operator would see in the control room. So we have the tank level, the pump input here, and the pump output here. And there's a pump RPM here which I can change, and if I increase this pump RPM, the PLC actually increases the pump RPM over here as well to keep the level of fuel balanced in the tank. Now that at the moment is a completely undefended system which can be attacked. Now there are different ways of attacking it. It could well be that someone, a service engineer out in the field, plugs a USB stick into a remote telemetry unit or a distributed control system, or it could be that you have some piece of malware which comes down from your corporate network through a connection, or some places they allow email in the control room, and what I've done here is simulated that. So we have an email which appears to come from Vago, people who manufacture the PLC, with an updated manual, but also some information on critical patches that need to be applied. So the control operator goes, "Oh, I must have a look at that," and he clicks on it to open it. What he doesn't realise is there is actually a piece of malware in that update which is now going to attack the PLC. So we have running now some malware. If we look back up the top, we can see that there is an overflow happening. The input pipeline is being driven. The system is running up and filling the tank. But in the control room, there is no idea. So we have an alarm sounding now. That tank is actually overflowing refined product out the top because it's full. In the control room though, the operator thinks everything is normal. And the PLC itself has died because it has now been overwritten by the attack. But all is not lost. It's possible for us to defend that. I'll just quickly reconfigure the system to include the Tofino firewall. What I've done now is actually include the Tofino device, which you've heard Eric talking about, and Ayman very kindly mentioned before lunch. This is an industrial firewall. It's capable of actually doing deep packet inspection on the protocols that are being used for industrial control. In this case, we're using Modbus, but it can cope with OPC and IP and some other protocols as well, and there are more coming later this year. So an ordinary firewall like Cisco or Juniper, what they can do is open a port which allows the traffic through. They can't do a deep packet inspection on it. However, these things can, so I can interpret the data, and if I'm getting illegal commands, I can deal with them. So if I now run that attack again, I'll just close the old one down. What will happen, as far as you're concerned, is pretty much nothing, because the attack will be run, but up here, we have standard pipeline operation, and over here as well. We're getting alerts though on the screen that are telling us that illegal traffic is being blocked. So the Tofino device is actually detecting illegal packets and is stopping them. But if I want to change the pump speed, if I want to do the control, I can send the legitimate command, because the Tofino device recognises that as a standard command that we're allowed to send and will allow it to pass. So that is providing protection at the end of the system against attack. In addition to that, we've got the reports coming through at the bottom of the screen, but also over here we have the McAfee Nitro solution. This is the Security Incident Event Management System. This is being sent the reports by the Tofino device as well as them going to the central management platform. We have integrated some software into this which is capable of understanding the industrial control system outputs that are being sent by the Tofino devices. So in the bottom corner here, we actually have a screen which indicates that we have Modbus unauthorised write requests trying to be sent to the PLC, and it can also show us suspected denial of service attacks, buffer overruns and so on that are being sent. So this is capable of identifying all of these outputs from the Tofino devices for monitoring purposes. And this is what Paul Dory was saying, you've got to monitor your systems. It's no good having some kind of protection. You need to know when that protection is actually doing its job and someone's trying to attack you. If I select these unauthorised efforts and I start to drill down, I can get a list of all the different incidents that we've seen. Of course, these are all the times I've run the demonstration over the last couple of days. If I click on one of these, the system goes away, and in the bottom of the screen here, it has now retrieved all of the data relating to that attack. So it will tell me the time and date that it's occurred. It shows me the IP address that the attack has come from, in this case, of course, control workstation, the addresses of the device or devices that are under attack, and also, if I scroll down, it's showing me the contents of the packets. So it allows me to identify what kind of attack is going on out in the field. So very quickly, I know that there's a problem, where the problem originates from, where it's going to, and what is trying to happen. That means that I can respond very quickly to isolate these systems, to replace them with clean ones, and I can stop what starts off as a minor incident escalating into a major incident. In addition to this, we've also got McAfee whitelisting technology, so I have the ability now to install whitelisting on the control workstations to stop attacks from coming in at that point. But of course, this system doesn't just defend against malicious attacks, it's also capable of defending against things like broadcast storms. If you look at the industrial search statistics, something like 80% of incidents are actually caused by equipment malfunction rather than by deliberate attack. These systems are also capable of defending against the broadcast storms if you've had an Ethernet router failure or something of the sort, and that gives you additional protection and alerting capability, which the McAfee CM is capable of understanding. So you have much greater monitoring and situational awareness of what your network is up to. At that point, I'll come through and take any questions you might have, and thank you for your time so far.